right. So good, you guys. So we're gonna continue with chapter 2.6 and 7 and 3.1 because your homework is due this coming Wednesday. So quite a bit of homework here. So I'm going to share the screen and we will start the class. So we talk about 2.6 on Monday. So we'll continue. So on 2.6 on Monday, we talk about the addition, subtraction, multiply, and divide, and how to find the domain, especially on the division part. Today, we'll talk about the composition function. What is a composition function? A composition function is where you kind of like substitute into one function to another function. So for example, is f, we call it dot here. So f dot g of x, it means that you do the, you take the function of g of x and you substitute back into the function of f of x. So another meaning when I talk about substitute here is that, so what happens if you have this function f dot g of x in this case is you take the g of x function, you put a value in, and the output of the value will be inserted back into the f of x function. And then you will get your final answer. So this is the meaning of f dot g of x, means you start from the back all the way to the back. You put the g of x function into the f of x function. Okay. It can be done by doing the other way around, g dot f of x. So that means that instead of doing gx, this time you do the f of x first. Or I always tell my students to start at the very, what function you want to look at the very end first. And then after that, put the f function of x into the g of x function. So for this case, it will be f of x first, then g of x. Now, no matter what way you plug in, you need to watch for the domain. This is the main part of the domain here. So since if you want to find the domain of f dot g of x, you have to find the domain of f dot g of x together. And you have to find the domain of g of x together. So what do you mean by and in this case means this is what we call as intersection, means both of these has to be coincide. So the reason why you need to find the g of x is because you have the g of x starting point. So if there is some domain restriction or there is a domain issue here, then you cannot even put this g of x inside into this function. For example, if this is a g of x is a square root function, we know that square root functions, you cannot be negative inside. So the domain, when you plug things down in here, you cannot plug in -3, -2, -4, these numbers inside. You can plug in 0, 1. So this is already the domain of it. So that's why you need to include the domain of g of x first. Then figure out what's the domain of f dot g of x. Then you can put them together. Same thing happens to the g dot f of x. So the domain in this case is the domain of g dot f of x and the domain of f of x. Since f of x is the first step we use, so we have to figure out what is the domain of that. So this is usually how we figure out the domain for this kind of functions. And it can be done by doing g dot g of x. Means that you take g of x into g of x, and it can be f dot f of x, means f. So what it means here is if you have g dot g of x, means that the input of g of x, the output, you put it back into the input. Then you got the output back. So this is what it means by g dot g of x or f dot f of x. You just the input will, the output will be put it back into the same input. So the domain is still going to be the same kind of domain that we mentioned here. So this is kind of the domain, the composition function for this case. So we'll look at some examples here. For example, will be number 6, and then we'll do number 6, and then we'll do something more difficult of that. So first thing first is they want you to figure out what is f dot g of x, g dot f, and g dot g, and find a domain for each of this. So for question number 6, you need to find f dot g of x. So what is f dot g of x is you need to substitute the g of x because it comes in last into f of x. So g of x in this case is given us by 5 minus x. So what do we do here is now we take like a substitution. You take this g of x, put it back into the f of x. So you will get 3. The x will be replaced by the g of x plus 5. And since the g of x is 5 minus x, so you just replace this by 5 minus x. And you just do some basic distribution and combine like terms. So you get 15 minus 3x plus 15 plus 5. Sorry. I think I recorded. So this is actually 20 minus 3x. Now you need to figure out what is the domain of this function f dot g of x. What is the domain for him? So first look at this 20 minus 3x. What is the domain of that? Anyone know what's the domain for 20 minus 3x? Domain means what x value can you take here? Anyone know what's the domain for this? This is a polynomial. This is a straight line. If you draw this, this is y equals to mx plus b. What is the domain for that? Anyone? Straight line, domain is... This is domain will be all real numbers. And g of x is 5 minus x. So your domain in this case is also going to be all real number because it's a straight line. So when you do the end of this, so your domain in this case will be all real numbers. So, so what you found out here is if your domain of fx, if the domain of f is all real numbers and the domain for g is also all real numbers, then no matter what you dot f dot g, g dot f, f dot f, g dot g, your domain will be also all real numbers. So this is kind of like one of the rules that we know. Okay, so make sure that you understand that. So like fx 3x plus 5, this is domain is all real numbers because it's y equals fx plus b. It's a straight line. And g of x is also all real numbers. So when you do the composition of this, it's still going to be all real numbers. Part B is asking us to do g dot f of x. So in this case, it means that you take the f of x, in this case 3x plus 5, and you plug it into the g of x. So you'll be 5. So when you put this into the g of x, will be 5 minus x. And this x will be replaced by g of x, in this case 3x plus 5. And you distribute your negative. So you get 5 minus 3x minus 5. So both the 5 will be 0 up. So your answer is negative 3x. And the domain here is, since, as I told you, your f and g is domain is all real numbers. So if you do the composition, your domain is also all real numbers. And C, we are doing g dot g. So that means that you take the g of x, in this case is 5 minus x, and you plug it back into 5 minus x. So 5 minus x, but our x will be replaced by 5 minus x again. So this is what happens when you do g dot g of x. Your x will be keep on replacing by the original function, in this case 5 minus x. And again, we will distribute your negative here. So it's 5 minus 5 plus x. Again, 5 minus 5 is 0. So your answer is x. And the domain for this, again, because of f and g is all real numbers, your domain is also going to be So this is how we do composition functions, f dot g, g dot f, and g dot g, and it can be f dot f, and it can be even worse. It can be f dot g dot f. So it can be like multiples, like 3 of them. So can someone tell me which function do we start first if I got f dot g dot f? F function first or G function first?
F function first.
Yep, you always look at the back here. So that means that you take the F function first. Let's say the F function we have is what, 3x plus 5, right? So you do 3x plus 5. And then you plug 3x plus 5 into the G. So you will have, which is this one, 5 minus 3x plus 5. And if you simplify this, this is negative 3x. And then now you plug this negative 3x into 3x plus 5. So your answer will be 3 times negative 3x plus 5. So it's negative 9x plus 5. So this is your f dot g dot f of x. So it can be a lot. So make sure you go at the back and then slowly work it up front. So from right to left. And the domain, since f and g is all real numbers, so the domain here is also all real numbers. Okay. So it can be multiples. So and you will see multiples when you go to calculus 1. Okay. Next question we have is, so sorry. We'll do some word problems here because this is the one that a lot of students. So I'm going to save all this so you can, please, I will save this and make sure you get, refer this into your D2L. So you'll be in your D2L. So this is, today is 8/25, page 1. Oh, because of that, I just put 8/25. So we're gonna talk about some word problems. So that would be question 12. This is still 2.6. So let DT be the number of birth and DT be the number of death in the United States, and T is the year. So when T is 10, represent the year 2010. So if the population PT is T, find is a population, find the percent change of this. So in order for us to find the percent change, the percent change is always taking the difference over by the population times 100%. Okay, and the percent change given as the formula, the function is CT. Now, when I say difference here means that between the people, that is the babies, and the people who die. So in this case, the BT is the birth and the DT is the death. So it will be BT, the birth, minus the DT, the death. So how many people die and how many people are birth, over by the population, PT, times 100%. So this is what we call as the percent change here. So you always do the difference, which is the birth minus the death, over by the population times 100%. So this is the formula for finding the percent change. Then the question is asking, what is C13 is? So if you look, that means your T in this case is 13. So what year is it when I say T is 13? This is what year? Anyone? It says when T is 10 is 2010. So 13 means what year? You guys are
2013.
Yep. So this is 2000. In 2013, we are looking for the CT. CT in this case is the percent change in US. So you are looking for the percent change in US during 2013. That's what they were asking for. So this is not that difficult. The reason why that we cannot do any calculation here is because the question did not provide us the function for BT, the function for DT, and the PT. So these three functions is not given to us. So that's why your formula is all going to be in the BT and DT and PT form, unfortunately. All right. And then there is another word problem. Again, these all word problems you will find in when you do your home or your online homework in this case. So that's why I want you guys to know how to do this. The number of the bacteria N in the refrigerator is given us by this formula. And where capital T in this case is the temperature in Celsius. So that means that when you put food into refrigerator, your food is warm, but when you put in there, it's getting cold. So the bacteria will grow no matter what you have. So that time that is given us by this function where T is the temperature and is the number of bacteria. And then what happened is once you remove the food from the fridge, the temperature function is given us by TT, 3T plus 2, where T, the little t here is time. So make sure that the capital T is temperature, the little t is time. So when you remove the food out from the fridge, your food will get warm based on the time, right? The longer you put out the fridge, the more time. And as you know that the more longer you leave out from the fridge, the more bacteria will grow. So that means the question A here is asking us to figure out what is N.TT. So in order for us to find N.TT, what we need to do is we will take the TT, because the TT is at the end, 3T plus 2, and we substitute it back into the capital T. So you will get 10, 3T plus 2 squared, because this is usually T, minus 20, 3T plus 2, plus 600. So what do N.TT means? It means I take the 3T plus 2 and substitute to both capital T here. And you have to simplify this. So first thing is we need to do the 3T plus 2 squared. So I would really suggest you guys to FOIL this one out, because a lot of students, if you don't FOIL it out, a lot of students make this mistake. Can someone tell me what is this 3T plus 2 squared if you think about not FOILing it? Anyone? 3T plus 2 squared? I will distribute this one. This is negative 60T plus minus 40 plus 600. Anyone know what is 3T plus 2 squared without FOILing?
Is it 9T squared plus 10T plus 4?
That will be wrong. So a lot of students, that's why it'll be wrong. So a lot of students just give me 9T squared plus 4. That is also wrong. So the middle term is always the one that plays trick. And if you want to know the shortcut without FOILing, what you do here, class, this is very important, is you take all these numbers and you multiply it. So what is 3T times 2? 6T, right? Times another 2. What's 6T times 2? So 3 times 2 times 2 is what? 12T. 3 times 2 is 6. 6 times 2 is 12. So this is the correct way to do it. If you do not know how to do this way, the shortcut way that I showed to you, then I will always want you to FOIL out, because FOILing will be the best way. I think you guys will FOIL and you will get this. Okay. And some students ask me, is that always work? I will say yes, the trick always work as long as this power is 2. And the trick will not work if it's power 3 or 4 or 5, 6. only power 2, only squaring binomials. It works that way. But don't forget, this one has 10 in front. So what you need to do is you have to take this fellow and multiply this by 10, because there's a 10 in here. So you have to distribute a 10 in there. So you will get a 90t squared plus 120t plus 40, because 10 times 4 is 40. And now you need to combine, like, then you have to distribute your negative 20 in here and then plus 600. So you got a 90t squared in this case. What how many t's we have? 120t, take away 60t, we got 60t. The 40 and 40 here becomes 0, so you got 600 still. So this is the n dot tt function. And the question asking us, interpret this. What does this mean? So does anyone here know what is n dot tt stands for in words? What does this function means? What does this little t stands for? Is that temperature or is it time? Temperature or time?
Time.
Time. And what is the n stands for?
Number of bacteria that's growing.
So this is actually the number of bacteria in the food based on time. So it's a number of bacteria in your food based on time. Okay, so this is not based on temperature, it's based on time. So how many bacteria we have based on time in this case? In order for you to do question B is asking us to find the number, the bacteria after 0.5 hours. So this is easy to do B here is you just need to find what is n dot t, where your time in this case is half an hour, 0.5. So what you do here is substitute this into this equation. 90 times 0.5 squared plus 60 times 0.5 plus 600. You need calculator on this one. And whatever answer you get, that will be your answer. I think I leave that to you because you guys should know how to use your calculator to punch this one out. So make sure you check my key for that. So B is actually quite straightforward because they just need to plug the 0.5 into the time. So that's why it's very straightforward. But in order for us to do part C, you want to find the time when your bacteria reach 1500. So what happens in this case is you have to use back this equation. This is the bacteria. And this time you need to find T. So this is 1500 for the number of bacteria, 90t squared plus 60t plus 600. So this is the form. This is the equation that we found early on in the n dot t. So since this is a quadratic, so we have to make this equal to 0. So this 1500 I have to move over here, and since I move the 1500, it becomes negative. So this is 90t squared plus 60t. What is 600? Take away 1500. 900, negative 900. And now you have to factor this. This is a quadratic. You have to factor this because it's equal to 0, or you have to use a quadratic formula. Now, before you try to factor it or you do your quadratic formula, make sure you reduce this equation because those numbers are huge, 90, 60, 900. Can someone tell me what number can we divide here? What's the common factor? What number can go to 90, 60, and 900? So you find out that the zeros can be canceled because 1 0 can be canceled. Because it means you can divide by 10, right? What else? 9, 6, and 90. What number can you divide by 9, 6, and 90?
3.
3. So you divide the whole thing by 3. 0 divided by 3 is still 0. This will be 3t squared plus 6 divided by 3 is 2t. And 90 divided by 3 is 30. So now you get into here, then I will suggest you to either use the quadratic formula or factoring. I will suggest use the quadratic formula. Can someone tell me what is the quadratic formula is? This is important. If you doesn't know this, you better pay attention. Anyone know the quadratic formula? Negative b plus minus square root of b squared minus 4ac all over by what? 2a. And your a in this case is 3. Your b in this case is 2. And your c in this case is negative 30. So I will put all this into the ABC here. So it'll be negative 2 plus minus. When you square the b, the 2, which is 4, b squared is 2 squared is 4, minus 4 times a is 3, and c is negative 30, not 30, because if you get 30, you get it wrong. All over by 2 times a is 3, so 2 times 3 is 6. So now you need to use your calculator to figure out what is the one inside this square root. So you take 4 minus 4 times 3 times with negative 30. Oops, sorry. Times with 30 negative. So 4 times negative minus 4 times 3 times negative. This is actually is 364, and you have to take the square root of it. So this will give me 19.0787. So this will give me negative 2 plus minus 19.08 divided by 6. Now, how many answers you will get here, class, when you use quadratic formulas? Anyone know how many answers? You should know this. How many answers you should have? Because of the plus minus, you should have how many answers? 2 answers, right? However, the negative answers that you have, you cannot take. The reason why you cannot have a negative answer is because this is time, and time is always measured in positive, cannot be negative. So in this case, you just need to get rid of the negative. So you do negative 2 plus 19.08 divided by 6. Because the minus 1 will give you a negative answer. So you take this number that we have, 19.07 something, minus 2, because that is the negative 2, and you divide this by 6. So the time in this case will be 2 point something, 2.85 seconds, hours. It's not in seconds, this is in hours. So this is your your bacteria reach 1500 when your time is around 3 hours, 2.85 hours. And the negative, you can skip it because of your time is cannot be negative. If this is just x, means normal x variables, then you will have 2 answers. You do need to include your negative because x in this case is not time, x is another variable. Someone have questions? Yep. You guys all right here with this question? And I'm going to save this as H2. Questions you guys have? So this is how we do the last question on 2.6 here. I'm gonna get a new one. Now we're going to talk about 2.7, which is the inverse function. So the inverse function, the notation is given us by this f negative 1x. This is the inverse function notation. So how do you figure out an inverse function? In order for us to have an inverse function, it has to be a function and it has to be one-to-one. Okay. What is the meaning when I say in order for it to be function is it has to pass the vertical line test. And one-to-one means you have to pass the horizontal line test. So in other words, if you guys know what a vertical line and horizontal line test is? Like a vertical line, if I give you a graph like this, does this pass the vertical line test? That means any vertical line, you only intersect how many times? One time, right? So this pass the vertical line test. Do this pass the horizontal line? So same thing, you draw the horizontal line. How many times it cross when you draw any horizontal line? It cross sometimes 2 times or 3 times. So this does not pass the horizontal line test. Okay. So in order for you to have an inverse function, you have to pass the vertical line test and the horizontal, and this is and both of these tests. Okay. What happens if you, like this case, if you do not pass the horizontal line test? So we will perform what we call as domain restriction. What is the meaning when I say domain restriction is we will restrict the domain. That means we don't take the whole function. We just take part of the function where it will be past the horizontal line test. So what do we do here is we erase. So we probably will erase. So instead of taking the whole thing, which is no good, so probably I will erase it till here. So instead of taking the whole function, I will domain restrict this into just this part. Now what happened is that, does it pass the horizontal line test if you restrict the domain? Yes, because if you draw the horizontal line, you only cross at one time in here. So this is what we call as domain restriction. So same thing with like parabola, with x squared. We know x squared is a parabola. So x squared does not pass the horizontal line test because if you draw a horizontal line, it crosses twice. So what do I do is I will do a domain restriction. So the domain restriction can be picked, either you take the positive side or you take the negative side. So the domain restriction here is x can be greater than 0, which is the positive side, or x is less than 0, which is the negative side. So once you have a domain restriction involved, then this will pass your horizontal line test. So that's what happens when you guys have an inverse function. When you guys do not pass a horizontal line test, you restrict the domain in here. Okay. There are some properties about the inverse function. I'll name some of them. One, if you dot the inverse function with the original function, you get exactly x. And if you switch them around, if you do the f dot inverse function dot the original function, you get x. So this is the first property that we have that you figure out for inverse function. So if you dot the two functions together and you interchange it, you've got x. The next one is if the domain of the original function is the same as the range of the inverse function. And if you switch it around, it also works that way. The range of the original function is the same as your domain of the inverse function. So this is the second property that you have. If you talk about coordinates, if your original function has the coordinates of x, y, then the inverse function will have the coordinates of y, x. So if I give you coordinates like 3, if the original function is 3, 1, then the inverse function will have 1, 3. You have to just swap them around. Okay, this is talking about coordinate system. If you talk about graph, your function and the inverse function, both of these functions will be, they have what we call as, well, coincide with y equals to x. Coincide means that if you if you draw in a piece of paper and you fold it on y equals to x, both the function and the inverse function will kind of like combine or stick, like they all merge together. Don't forget, y equals to x, the line is the one that go horizontal. So if you have a graph paper, if you connect from one box, n box, to another n box, you know, because your slope is 1, that is y equals x. So if you have a piece of paper, if you draw that the y equals x line and you fold it in between them, you find out that they coincide, they match together. So these are the few properties that we have for inverse function. And then the last thing is, how do we find an inverse? This is important, so I have to start here. So how do you find an inverse function in this case? So in order for us to find an inverse function, the first thing is interchange your x and y. So what do I mean by interchange your x and y is you take all the x, change it to become y, and all the y or f of x to become x. And then you solve for y. Once you interchange it, you solve for y. That means you make y by itself. And then the last thing is you just change back your y into the inverse function. So these are the 3 steps to find. How do you find your f of x in this case? Your inverse function is this. This is very, very important. About the properties, usually the second property is also very important, because if you know the domain and range of the original function, if you want to find the domain range of the inverse function, you just flip-flop them. Just flip them around. Okay. So I will go through some examples here so you can, so these are all what we talk about here. So like the first example is easy because this is the fx and fx. So if you want to find the inverse function of this, you just flip your value around because it's given us by coordinates. So this one, if you flip, is still going to be -2 and -2. This one, when you flip, will become, instead of -1, 0, it will be 0, -1. So this is very easy. So I think you can just do this on your own. You just flip your x, y, that's how your coordinates around, your x and y around, and you get yourself an inverse function. Okay. Next is we're not going to do this one because you can look at my notes for that. So the next one in this case is asking, do this have an inverse function? So in order for us to do the inverse function, it has to be 1-to-1, or it passes the horizontal line test. So so in order for, if I give you coordinates, how do we know that this one has an inverse function? You look at your y value, and if they share or they have the same y value, that it is no, they don't have an inverse function. So in this case, you notice that the -2 is the same here, the 1 is the same. So in this case, this is not, it doesn't have an inverse, no inverse function. You guys with me here? So in order for you to have an inverse function, the value here has to be different. So for example, if you look at this example, the -2, 0, 2, 4, 6, this has an inverse function. The reason why this one has an inverse function is because if you look at your y value here, none of those are the same. So that's why it has an inverse function. But if you look at this one, it has that 1 is sharing, that 2 is sharing, that is why it's not an inverse function. This one, it also has no inverse function. The reason why is because it fails the horizontal line test. So if you draw a horizontal line, it crosses 2 points. So this one has an inverse function because it passes the horizontal line test. So when you draw a horizontal line, it crosses at 1 point. So that's why it passes the horizontal line. So it has inverse function. You guys all right here with figure out if this has inverse function or not?
Yeah.
Pretty straightforward type. Usually, so we're gonna do a like this question here. This one is the one we need, and then I change question 8 to another question. Question 7 is given us by this. This x less than or equals to 0 is what we call as your domain restriction. ST, how can I spell T? Strict ST. Oh my God. Yeah, there you go. Cannot spell today. So that means that this is x squared minus 2, which is the same as a parabola. And as I told you, a parabola does not pass a horizontal line test. So it has a domain restriction. Can someone tell me, is this the positive or a negative side of the function? Are we doing the positive or the negative?
The negative.
This is a negative. Okay, so this is very important. So part A is asking us to figure out how do we find the inverse function. So in order for us to find the inverse function, these are the 3 steps. First, you have to do the switch your x and y around. So this is your y, this is your x, so I switch them around. So f of x will become x, and then x will become y. So this is the first step you do, is switch your x and y around. Second step is you have to solve for y. So in this case, I will get rid of the -2. So x plus 2 is equal to y squared. And then I need to get rid of the square root, the square, so I have to take the square root. But every time when you take the square root, you need to have a plus and minus. Okay, so if you put your answer as plus minus square root of x plus 2, you get it wrong. The reason why is because it does have a domain restriction, and this domain restriction plays an important role. So since you told me it's negative, so which one we're gonna take in this case? Plus or minus? We will take the minus. We take the negative because of the domain restriction. Okay, that's the reason why we take the negative, is because of the domain. If this is greater than equals to 0, then you take the positive in this case. And the last thing you need to do, this is the second step. The last step you do is change the y here to become f of the inverse. Okay, change it to become inverse. So this is how we how do we find the inverse function of this? And then secondly, you have to draw the graphs. Okay. Oh my God. So how do you draw the graph here? So I need to probably draw it over here because how do we draw x squared minus 2? So x squared is a parabola. Minus 2 means we go down to -2. So this is your x squared minus 2. However, because of a domain restriction, you only take the less than 0, the negative part of x. So you need to erase this part. So this is your f of x. Now, if you draw the square roots, the negative square root of x plus 2, this is the inverse function that we have here. Okay. So square root function looks something like this. This is the square root function. So when you do x plus 2, it means you move to the -2. That is the meaning of x plus 2 in there. Means you move to the left -2. The minus sign means you have to reflect this on the x-axis. So what happened is that this little green line that I shaded or I fuzzy it, it will look something like this. Okay, so this green line is your inverse function. And if you draw the y equals to x line, and if you fold this on the line here, you find out that this red will be coincide with this red, and then the other part will coincide. So when you fold it, it will kind of like stick. It will be both of them will stick together. So so this is what your graph will look like in part B. Okay. What is the relationship? The relationship between these two, if we look at graph, is reflected on y equals to x. So mostly the relationship between the function and its inverse function is always reflections in this case. And then D is you have to find the domain and range of the function. So if you look at the function, the domain is very easy to find because it's already given to us by the domain restriction, which in this case will be x is less than or equals to 0, which is given to here. Or in other words is negative infinity to 0 with a bracket, if you want in interval notation. The range, you can look at your graph, the red line. Since you go down -2 here, so your range in this case is from -2 to infinity. Oopsie. Your range here will be -2 brackets to infinity. So, and what happens to the inverse function? The domain and range will be switched around. So means that your domain in this case is the same as the range of the original, which is -2 to infinity. And the range of the inverse function is the same as the domain, which is -infinity to 0. So just want to point out to you guys that this is the property of what I just told you. The domain and range flip-flop around between the function and its inverse function. This is very important. Okay. So this is how we do this kind of question. Anyone have any questions for me with this? All right. So so instead of doing question number 8 here, I will change the question 8 to a new question. So I will give you f of x equals to some let's say 3x plus 2 over by 4 minus 5x example. So first question is the same question. I want you to find the inverse function. Now, I do not want you to draw this, to graph this, because you haven't learned it yet. So we will skip part B and part C, but we'll go to part D. I want you to find the domain and range for both the function and the inverse function. So we'll skip part C, B and C, because you haven't learned how to graph this function yet, which is a rational function, which is, if you want to graph this function, it looks very similar to number 6. You see number 6 here that you have. So it's very similar to this question 6 here. So that's why I do not want you to. And you only learn that after test 1. So that's why, no, after test, no. Test 1, sorry. You will learn this right at the end of, right 4.2, which is right in test 1. So, so how do you find the inverse function here is, again, switch around your x and y. So your y will become x and your x will become y. And then you have to solve for y in this case. So because there are two y's in here, last time you only got one y, it's easy to solve. This one has two y's. So what you do is you multiply this to that side. So you will get x times 4 minus 5y equals to 3y plus 2. So you multiply the denominator to the x side and you distribute your x. So you get 4x minus 5xy equals to 3y plus 2. Now, this is back to your solving equation. So do you guys know how to solve 4x minus 3 equals to 2x plus 5? You guys know how to solve this equation? How do you solve that equation? Anyone? You should know how to solve this equation, right? This is very simple.
Yeah, do you add 3 to the other side and then do
So
minus
you
2x?
You move the non-x on this side and you move the x on the other side, right?
Yeah.
So this is the same way that you do here is because you want to solve for y. So how do we solve for y in this case is we will move, this is a y, so that's a y. So we move this y over here and we move the non-y over here. So what we have in this case is the 4x still here because it's no y. This 2, because it's a plus, become minus 2. 3y is still here because the y is here. And because this one is a negative, it becomes positive 5xy. So what I do in this case is if you have two y's in your equation like this, is you want to make all the y's into one side because that's how you solve for y. And since they're all on one side, you can factor the y out and you get 3 plus 5x. And in order for us to get rid of this 3 plus 5x, I divide both sides by 3 plus 5x. So this will be gone. So this is your inverse function. So this is how we find the inverse function. So the next thing we're going to talk about, anyone have any questions? As I know I go quite fast here. So can someone tell me what is the domain of this function? Anyone? We talked about this before on Monday. When you have a denominator, a fraction like this, what happens to your domain? It cannot equal to what?
0.
0. So can someone solve for x for me? So your domain here is all real numbers. X cannot be what? Anyone solve for x? This is easy. 4 over 5 or 5 over 4? This will be 4 over 5, right? Now, how do you find the range? Now, finding range, again, you need chapter 4 because now you're in chapter 2. So I just leave it blank first. Okay, I leave this blank first because later on we'll fill it out. Now we find the domain of this. Do you guys know how to find the domain of this one? Because that's the domain of an inverse. Again, you set this not equals to 0. Your answer is what? All real numbers. X cannot be what?
3/5.
Negative 3/5. Don't forget the negative. And the range, again, you need chapter 4 to do it. So now my question is, how do we figure the range for these cases? Since you doesn't know chapter 4 yet. So it's very easy, the properties. The domain of the original function is the same as what? The range of the inverse function. So this range will be all real numbers. X cannot be 4 over 5. And what happens to the range of the original function is the same as what? The domain. So the all real numbers, X cannot be negative 3/5. So this is how you figure out the domain and range for this case. Actually, you find the domain for both of these functions first. And once you find the domain for both of these functions, then you just switch them around to find the range of those functions and the inverse function. So this is for the original function, and this is for the inverse function. And this question is coming up in the test one. Just to tell you that. But definitely different numbers, right? Not the same number. I mean, it's going to be something like that, but with different numbers. And you will get this in your homework too. Anyone have any questions for me? Save this first before I. And all this is posted in D2L. So once we are done, I'll post it up there. It's attendance time. So please go use the chat room. Sorry, use the chat room and do your attendance. You guys know what means attendance. Yep. Attendance. Questions for me before we move on to chapter 3, because you got 3 homework due on Wednesday, 2.6, 2.7, and 3.1. So this is 2.7. So we got a few more minutes left for 3.1 here. Okay. Anyone have any questions for me? Next one we're going to talk about is chapter 3 here. So much things going on. So chapter 3 is going to be on quadratic. Okay. So when we talk about quadratic functions, the quadratic functions is given us by this formula, ax squared plus bx plus 2. So in chapter 3, we start out with power 2, the quadratic, and then we go on to power 3, power 4, power 5, the cubic, the quartic, which is power 4, and then the 5th and the 6th and so on. So we start with easy one first. So once you got to the quadratic functions here, all the graph of the quadratic function, the x squared is a parabola, and which we do draw a little bit of parabola before. Here's my paint. And the parabola that we have in this case is either when you draw a parabola, it can be open upwards or it can be open downwards. It all depends on your A, this A that you have. So if your A is positive, it's going to be open upward, okay, upward here. And this is going downward if your A is negative. Okay. And what is the axis of symmetry? Axis of symmetry is where you cut this parabola into half, this line. So this line is what we call as your axis of symmetry, the red line here. And this parabola will have vertex. What is a vertex? The vertex is the turning point. This is called a vertex. And usually the vertex, we denote that by HK. So this is the vertex HK. So if you have the vertex of HK, then the axis of symmetry is going to be X equals to H. So whatever your X value, not the Y value is on the vertex, it will be your axis of symmetry. So when you do axis of symmetry, don't just give me H, give me X equals to H. For example, is if your vertex is 3, 2, and if I ask you what is the axis of symmetry, if you just give me 3 in your homework or your test, you'll get wrong. You won't get full points. You have to give it to me as X equals to 3. Okay, so this is very important. So a lot of students, when you do your 3.1 homework, they just put 3, and they will mark you wrong. Okay, so make sure you put X equals to 3. This is for axis of symmetry. This is what we talk about, open upwards and downwards. So if you open upwards, this vertex is called the minimum point. And if you open downwards, this vertex will be called as your maximum point. Okay. So, and how do you figure out maximum, minimum? It depends on your A. Are they positive or negative? So this is for the function of y, quadratic function, ax squared plus bx plus c. And you can also write this function into a standard form. So standard form in this case means you do ax plus h, not plus, minus h squared plus k. So you can change this from a quadratic function to what we call as a standard form. Now, the standard form is really nice. The reason why I said the standard form is really nice is because the h and k that you have here is your vertex. So if you can write the quadratic form into a standard form, you automatically write this as your vertex. And don't forget, this is a minus sign. So that means if you have a negative, it becomes plus. If it's a plus, it becomes negative, your h. So that means your h is actually you have to, when you write a vertex, you have to flip flop. You have to do the opposite of it. Okay. So how do we write from this form to a standard form? Is you have to do completing the square. And doing completing the square is a lot of work. I can show you the work and then I give you the shortcut. The first is if you have if you have a leading coefficient a, you have to divide everything here by a. So that means your x squared is by itself. Okay. Second is you have to move all your x on one side. So that means you got this x, and you have to move your c to the other side. So this is your second step. So the c that you have to move it to the other side. And then the third one is you have to take the b that you have here. You have to divide this by 2 and square it. This number, let's say, is d. You have to add it to both sides of the equation. So get equation, you balance it out. So that's the third step. And then the fourth step in this case is these three terms, ax squared plus bx plus d, can be factored to become x plus b over 2 squared. And then this will give you fx plus d minus c. And then after that, the last step you need to do here is to move all this back into here. So f of x is by itself. So you will get something like this. And this number, the a number in front will be the a, and this number will be your h, and that will be your k. So that will be your vertex in this case. Some students ask me, is this a is the same a as the original one? I say yes. This a and this a is the same. So if you have 2x squared, then this should have 2 in front like that. Okay. Now, completing the square is very difficult. And if you look at your homework, they always perform this, but there is a shortcut I mentioned. And the shortcut is right over here using the vertex formula. So the shortcut, always a shortcut. In order for you to use a shortcut, you use the vertex formula. So if you do not know the formula, then you have to use the completing the square that I just pointed out. So you will take your h, your vertex is hk. It's gonna be negative b over 2a. That is your h. And your k is f of negative b over 2a. So, and hk is your vertex. So there is a shortcut to do it. So if your homework wants you to write this in a standard form, you use the vertex formula to find your h and k. And then after that, if your a is 2 or 3 or 4, you just put the a is 2 or 3 or 4. So that means this is the fastest way to find your vertex. And I would not suggest you to do the completing the square. You can, but as you know that this is way faster than doing that. Okay. The a also has some properties that we talk about here. So beside open outwards and downwards, positive or negative, if your absolute value of A is greater than 2, then your parabola will going narrow. If your A is between 0 and 1, absolute value of A, it become wider. So this is what happens to your graph. So example is if you have A is 2, your parabola will be, let's say this is a x squared. Sorry, my parabola looks weird. But if you have a 2, your parabola will become narrow. And if you got 3, it's even narrower. Okay, so the bigger the A is, the narrower it gets. And if you have 1/2, it opens wide. So this is what happens when your A is between 0 and 1. So that is the A properties here. And then if you want to know what is your y-intercept is always C. So 0C, it will be your y-intercept. So if a question wants you to find the y-intercept, you just look at the C, whatever number you have here, that is your y-intercept. That means this is where they intersect at the y-axis. And if you want to find the x-intercept, you have to set either the f of x equals to 0. So you can set this equals to 0, or you can set this equals to 0. So no matter what you do, you can always set one of these equals to 0 and you solve for x. If you set the original equation, this equals to 0, if you can factor it, good. If you cannot factor it, then you have to use your quadratic formula. And this is how you find your x-intercept. Okay. So these are all the goodies that we talk about for just this section, 3.1 here. This is all about 3.1. Quadratic. And we'll look at some examples in this case. Tough. This is a bootcamp class, I told you, right? It goes really, really fast. So this question is asking us to use this to write in a standard form and then sketch the graph and then find the vertex, axisymmetry, and x-intercept. So again, in order for you to write this in a standard form, there are 2 ways to do it. Either you do completing the squares like this crazy one, or you do the vertex formula. So for me, I will do the vertex formula. Oh shit. Should be saving that one. Crap. Too late. Hopefully you can rewatch this again for that page I forgot to save. So make sure you watch that. So so first thing is let's take a look at this question here. So let's write this in a standard form. So what you do first is find your vertex first, h and k. So in order to find your vertex, you use a formula h equals to negative b over 2a. Again, b in this case is negative 12, a is 1. So this will give me 12 over 2. So negative times negative is become positive 12. 2 times 1 is 2, so this is 6. So your vertex is a coordinates. It's going to be 6 something. And how do we find your y value, or in this case k, is you plug 6 into the equation. So you will get 6 squared minus 12 times 6 plus 144. So you just replace 6 into this equation. Let's see what you get here. 6 squared is 36, right? Minus 12 times 6 is 72 plus 144. So it's 108. Okay, so that your vertex in this case is 6108. But the question wants us to write this as a standard form. So standard form is y equals to a x minus h squared plus k. This is the standard form. Do we know a? Yes, a in this case is 1. So we can ignore it. Do we know h? H will be 6. This is your h and this is your k. Square plus 108. So this is the, is that correct? I think so, yeah, that should be correct. So that will be your equation of what we call as a standard form. Okay, so you're gonna write this in a standard form. So this is the fastest way to do it. Okay, and then you want to identify the vertex. Guess what? The vertex is here already. This is your vertex. Axis of symmetry, if you want to do the axis of symmetry, is x equals to whatever your h is, 6. So this is your axis of symmetry. And now you need to find your x-intercept. So in order for you to find the x-intercept, you can set this equation equals to 0, or you can set your standard form equal to 0. So I would set this equals to 0. X squared minus 12x plus 144. You know what? The quicker way, actually, the quickest way is not that equals to 0. It's actually this equals to, this is the quickest way to find it. So is that 44? Let me, is that 44? Oh, 44. Thank you so much. Yeah. My bad. Thank you so much for telling me, Kelvin. So this is actually 44. So that means this is wrong. I was like, huh? 36 minus 72 plus 44. Thank you. 8. Not 108. 8. I was like, this is a big 108 is really huge. This is 8, not 108. Sorry about that. Thanks for telling me, Kelvin. So your vertex in this case is 6, 8. So the axis of symmetry is x minus 6. So in order for us to find the x-intercept, you set this equation to become 0. So 0 equals to x minus 6 squared plus 8. And we want to solve for x. So we move the 8 over, become negative. And then when you want to get rid of the square, we square root it. Do you know what happens? You need plus minus. Do you know what happens when you square root a negative number? Anyone? What happens with a square of negative number? We'll talk about that on Monday too. This has become complex, right? So if you get a complex number, which is like this, then the x-intercept in this case will be DNE, does not exist. Okay, so this is how you figure out if an x-intercept does exist or not, is you try to solve for x on this equation. And if you came up to be a negative inside the square root, DNE do not. But if this is a positive, then it does exist. Okay. So what is the meaning when your x-axis is DNE? It means that your parabola will not cross your x-intercept. That's what it means. Okay. So what happens is we have to graph this. So the vertex in this case is 6, 8. Do we open upward or do we open downward? You're looking at your A. Is that going upwards or downwards? Is it open upward like this or open downwards? A is positive, so what do you think? It is open.
It opens up.
Upwards. Yep. And the axis of symmetry is x equals to 6, which is this one. Now, can you draw a graph with just one point? That's your vertex point. We cannot draw it. And so what you do is you have to pick another point to substitute. So I'm going to pick 5. any number you want here, or 0. We can use 0 here. What happens when you plug 0 into your x? You will get 44. So all the way up to 44, because that's your y-intercept. This is your other point. So you say it's the open upward. So your graph will be going through like this and like that. So this is what your graph looks like. And you find out that it does not, there's no x-intercept. It's because it will not cross on your x-axis here. So this is how you do your question here. And this is also in your first test. So I would recommend you guys to try to do this homework, especially with like this is a bit easy because it's 1. So maybe try like number 2. Again, try this on your own because it is in the key, the instructor notes, right? I told you there's instructor notes that you can use here. So, so this is how we figure out your standard form and how we graph, how we find your vertex, your x-axis, your axis of symmetry, or x-intercept in this case. I will do one more and then we'll end here. We'll save this. Sorry about that. I forgot to save the last one. The next one we're going to talk about is question 4 here. This time I give you the vertex. You need to give me in a standard form, so the opposite way. So the vertex is given us by the point -2, -2. And then they give me a special point, which is -1, 0. And they want us to write in the standard form. So the equation of a parabola in the standard form is a x minus h squared plus k. This is the standard form. So the question already provides us the vertex, -2, -2. So that was your hk here. So the good news is I know my h, I know my k. But now we need to figure out the a in this case. So how do we do this? Is we have to use this point, x and y. So what you do is you take all these points, x, y, and hk, and plug it into your equation to find a. So your y is 0. I do not know a. X is -1. H is -2. So 2 negative become positive. And k is -2. So this is an equation that we need to solve for a here. So first thing what we need to do here is move this, do the parentheses first. -1 plus 2 is 1. And then when you square 1, it's still 1. So this is actually is a minus 2, or 1a minus 2, because this times a is 1a. So a in this case will be 2. So solve for a, move it around. So now once I got a is 2, I just substitute this back into this, and that's my answer. So y will be y, a is 2, x minus h is -2, so 2 negative become positive, and k is -2. So this is the equation of the parabola in standard form for question 4. So I do this is not that tough actually for this kind. This is a tough one that we just did just now on top here. So try your best. This is the one that you will get in your test. So make sure you guys know how to do all this work, how to write in the standard form and graph and sketch and so on. Now the word problems that you see here is going to be mostly talking about maximum. So when they talk about maximum, when you do the word problem on this section, when they ask you for maximum or minimum, it means that you're looking for the vertex. Okay. So if a question is asking you to find what is the maximum, like part B here on this question 10, question 7, how do you find this? Is this is an equation. RP is -25 p squared plus 1200 p. So again, if you want to find your maximum or minimum, in this case maximum, because it's a negative, it opens downward. So you find the vertex. So vertex is HK. And the formula is the same as we just used, negative B over 2A. And this is your B, which is negative 1200 over by 2 times negative 25, because your A is negative 25. So this is become negative 50. And 1200 divided by 50, 24. So that will be my unit, find the unit price. So the unit price in this case will be 24. And then you want to find the maximum revenue. The maximum revenue means it's your K. So you plug 24 inside this equation. So negative 25 times 24 squared plus 1200 times 24. So whatever you get here in your calculator, that is your maximum revenue. So when you do your homework questions on this section 3.1, when they ask you for maximum or minimum, you just need to find the vertex in this case. Okay, that is the meaning of it. All right, so that is the end for today's class here. I'm going to save this to the last. So there should be 7 pages, but I forgot to save the one early on here. So only got 6 pages. So make sure you rewatch this Zoom to get this. Your online homework for this section is gonna, for this coming Wednesday is 262731. So better start working on it. So if you have any questions, please stay back and let me know. If you do not have questions, you may go. Anyone have any questions for me? Then you guys take attendance with you, right?